Thank you guys for joining me for this talk on cross-build injection attacks. I'm pleased to see so many people, and before we get started, I'd just like to know, is there anyone who in this room has heard before about the term cross-build injection attacks? Raise your hand if you have. Not so many. That's actually good, because hopefully you will pick something up new along the way. But to be honest, until the beginning of this year or halfway last year, I didn't know about them either. I mean, I had some fake notion about how your build could be vulnerable to some kind of attacks, but I really hadn't thought about it very deeply. But actually, working with one client who had a highly sensitive application really turned my eye towards this problem of vulnerable builds. Because it's pretty interesting that we put a lot of efforts into securing our applications, building safely, secure coding standards, applying best practices, keeping up with the latest updates of your frameworks so you don't have any vulnerabilities. And those are all good things to do and good things to have. There were many talks here at Java 1 as well relating to these topics. But the point that I want to drive home in this presentation is that you shouldn't only build safe applications, but you should also build your application safely. Otherwise, all your effort will be for nothing. And I hope I can show that and I can demonstrate it in this talk, and I'll give you some food for thought. And if not, come up and discuss, and we'll see. But that's the central premise of this talk. You shouldn't only build safe applications, but you should also build them safely. So now your next question is, of course, okay, how can I build my application safely? What can go wrong? And we'll have a good look at that during this session. First, a little bit about me. My name is Sander Mak. I'm from the Netherlands, where I work at a software consultancy called InfoSupport. It's a medium-sized, at least for the Netherlands, medium-sized consultancy. I focus mainly on Java development and architecture. In my spare time, I'm really interested also in some Scala development. Currently not for any production projects, but who knows. And in addition to that, I try to be really active in my Java user group as well in the Netherlands. So I do that by giving talks, writing. I have a blog, as you can see. So there's all kinds of stuff I try to do to keep up with the latest and greatest. So, trust. I mean, before we dive into any technical details, I think this is the most important thing to keep in mind. Who do I trust? What do I trust? And this is not just in relation to who's coding at your work, but also in relation to all the libraries, etc., that you use. And while I was researching this, I ran into this great article by Ken Thompson, and it's called Reflections on Trusting Trust. It's sounding kind of recursive, and it's also a kind of recursive story, so it's really a good read. I recommend it. Written in 1984, so before all the fancy stuff that we're working with today has arrived. But the central message still applies today. And in this story on Reflection on Trusting Trust, he has a nice story about the C compiler, which obviously is written in C. And in the C compiler, if you wanted to implement a new feature, you could do that, of course. But you could not use that new feature to implement a new feature because, well, the compiler didn't understand the new feature yet. So you had to do some clever tricks and workarounds to create a new feature and then compile the compiler with this old compiler, and then you get a new compiler that understands this new trick, and then you can rewrite your compiler using the new trick. So there's all kinds of dependencies and recursion going on, and this is all because you're using software to build software. But he also saw that it is not only used for good things, like adding features to compilers, but it is also a very good way to add Trojan horses to, for example, applications compiled with compilers. And he gives an example of the login command of Unix, and how you can create a nefarious C compiler, which throws in a backdoor into login, and you wouldn't even see it in the source code of the C compiler because of this recursive trick of learning the compiler new backdoors. So really, it's a tale of caution. And the moral is, you can't trust code that you did not totally create yourself. And even then, you have to trust your compiler. And he even says, even deeper, if you trust your compiler, well, you must also trust your CPU to do exactly what you think it should do. Well, of course, it's turtles all the way down, and the trust has to end somewhere. But just this, I think, a pretty nice story to read, and really shows how things can go wrong at places where you don't even think about it. So today, is this still something that's applicable? Well, maybe not at the C compiler level. I think we have a certified C compiler even that's proven to be safe, etc., etc. But that's not the point. I mean, there's lots of things going wrong currently, also on the security perspective. So just some headlines that I threw together that illustrate this point. One is the fact that an OpenSSH distribution got severely backdoored, and you would just use in any BSD distribution, you would use your port command to install OpenSSH, and it would download the source code and it will compile it. So you're compiling from source, so that should be safe, right? What can go wrong? And then still the backdoor was there. And that's all because of a breach in their build system. Similarly, if you look at the distribution of SourceForge, just recently they had a backdoor into PHP MyAdmin, which allowed hackers to access any of your databases if you weren't paying attention. And it was because of a corrupted binary in one of their delivery nodes. So yeah, how did it end up there? It's really a matter of making sure every node in your distribution network is safe. And so there are other stories as well. SendMail had a breach in their build system as well, which allowed people to inject code. And even worse, at GitHub, there was a hack that allowed you to put commits in any repository if you knew what this bug was. So obviously, this all has been patched and this all has been solved. But in the end, it should have been prevented, of course. And because it isn't, it is as well when we assemble our applications from binaries we use, from other applications we use, to pay very, very close attention to the security of the whole process of assembling your application. So you may still be thinking, okay, these are all like C-based build projects, and that article you mentioned was 30 years ago. How is this still relevant today? And for that, I'd just like to show you a very small example using Maven and just a Java compiler. Just to be sure, I have a perfectly legit install of Maven, so nothing hacked in there, and also a perfectly legit install of the Java compiler, at least I hope. That's what I've depended on so far. So let me show you a little example. In this case, and this will be the only code of the whole talk, and it will be the most trivial class you've ever seen, of course. It's a public class test with a main method in which we just print hi there. Okay? So it will be built using Maven with a super standard POM, just defining the group ID, artifact ID, version, packaging. And I have a definition for my Maven compiler plugin which says, okay, this will be a Java 1 source, and the target's Java 1.6 bytecode. I mean, what could possibly go wrong, right? So let's see. Do just a Maven clean install to build the whole thing. Success. Now let's execute it. So I'll add the class to my class path. I'm just going to execute it. Hey, that was not in our source code. What just happened here? Let's see. And there it is. It still says hi there in my source code. So something must have gone wrong. But where and why? And can this happen to you as well? That's the question that we're trying to answer here. So does anyone want to take a guess what happened here? Yeah? A transitive dependency that got pulled in that had that might be a possibility, but no, in this case, not really. So let me get back to the presentation. And for any one of you that's wondering, okay, well, I don't use Maven, so that won't happen to me. Actually, what I'm talking about, cross-build injection attacks, it applies to all the modern build tools in our Java landscape, and even outside of it. So whether you're using Gradle, Ivy, or whatever, everything that uses automatic dependency management and retrieves dependencies from a central repository, as does Maven, is vulnerable to attacks from the outside. And it may sound obvious, but we don't really think about it, right? Just a quick poll, who uses Maven here? Okay, whole room. That settles that. Okay. So a picture of the situation that we had. Okay, we have Maven right. Maven downloads its dependencies from Maven Central. Very convenient, very easy to use. But in this case, I would say that convenience might sometimes also conflict with security. There's an inherent trade-off, it seems. And what happened here is that Maven does not only download the dependencies for your application, but it will also download dependencies it uses for its own execution. So in this case, the Maven compiler plugin will be downloaded from the central repository if it wasn't already in your local repository. And it will be used by Maven to actually compile the code. Well, I made sure that there was not just the normal Maven compiler plugin that was in my local repository, but of course the hacked version, which replaced some code in my sources and compiled it and then replaced it back so nobody would see, only at runtime. So hopefully, in this case, my QA department would have caught this problem. If not, then, well, I rest my case, all else is lost. But you can, of course, if you have the possibility to inject arbitrary code into an application, you can do much more invisible things and much more dangerous things than just replacing a string in this case. So, I don't know, maybe inject a backdoor into your banking application so you, as a hacker, can log in and transfer money. Or maybe even if you're smarter, if there's a security vulnerability in a certain web application library, let's say Spring MVC, and it gets fixed, and the developer thinks, okay, good, got fixed, I'll update to the next version, and he updates to the next version in his Maven POM, and then you, as a hacker, nefariously replace the new version with the old version that still has the vulnerability, and nobody will notice. So, in this case, the change was obvious, but it doesn't have to be. So it's really something you should be aware of. A bit about Maven Central, because that's the example that I'm taking. I'm using Maven as an example here, but as said earlier, it applies to everything that uses a centralized repository. Maven Central is the most widely used Java repository. It has over 400,000 components. 7.5 billion requests per year. That's really mind-boggling. And more than 60,000 organizations around the world use this. And if you want some more stats, there's a nice Sonatype white paper or presentation that contains all these numbers. But really, what this shows is that if you can get into this Maven Central, if you can somehow make the people who use Maven Central, if you can inject yourself between them, that's really something. You want that as a hacker. Really. But it hasn't happened so far. At least not that I know. But if I can think of it, somebody else can think of it. Right? It's a prime target, but still, this doesn't mean that Maven Central or the repository is bad or anything. It's just that we should use it wisely. So what could go wrong? Well, since Maven just downloads jars and code in the open over the internet, all the caveats of using a normal internet connection apply. A hacker could position itself in between you, in between Maven in this case, which makes the connections, and Maven Central, and you request a jar, and you will get a malicious jar back. Of course, you might think, okay, haven't we solved this problem already using secure protocols, etc.? I will get back to that, but as it is, Maven just downloads things in the open, and things might go wrong with this scenario. There's also a slightly related scenario, in this case called DNS poisoning. in which case the hacker doesn't sit in between, but it somehow convinces the DNS server that you use that Maven Central is not at Maven Central, but at Hacker Central, for example, and it redirects the request to this nefarious Hacker Central, and it will send you just malicious jars and do it like that. So these are both transport level dangers and securities, and as I said, you might be thinking of some solutions to that, and we'll get to that. But what about this? What if Maven Central would be compromised? That would be something, right? I mean, I think they could go packing then. Nobody would use it anymore. So there's no known breaches so far of Maven Central. But what if it happened? How would it affect you? Would you notice? Or would you just download these jars anyway and put them in your build and run your banking application and everybody is happy, including the hacker? So all these different attack factors have one result, namely the fact that just arbitrary binaries may end up in your application. And it might be convenient to ignore this, because, as I said, I'm not aware of any place where this has happened. But I don't think that's a professional approach, right? I think that we really should be working together to prevent this from happening and to prevent people from trying to do this. And these cross-build injection attacks, I mean, there are countermeasures, and we will talk about them in the remainder of the talk. But you will have to work for it. It doesn't come automatically, at least not by default. Just for attribution, the cross-build injection term is not invented by me. It's a term coined by Fortify, their research department. They are a security club who have really nice software for scanning your applications for security holes, etc. And they identified this weakness in the whole build infrastructure of Java applications. So if you search for cross-build injection or XBI, you will either find my blog post or their white paper at the moment. And they found it first, and they recognized this. And it's sort of a nice term, right? It goes well with the cross-site scripting, the SQL injection, and all the other acronyms that we have. So if you have something to sell to your manager, you just say, we have to do something about XBI. And you will say, OK. So about the countermeasures. The first two attack scenarios that I showed were really something that could have been prevented by using HTTPS, right? Because man in the middle just isn't possible. You would have to have the certificate of the target, and well, that's not really going to happen. And also for DNS poisoning, the same applies. So if you're only able to access Maven Central by HTTPS, you would have at least prevented these attack factors. The fact is that Maven Central is it's a community service, right? And you saw the numbers, 7.5 billion requests per year, mind-boggling. So if you want to have HTTPS access to Maven Central, you will have to become a Sonatype customer. And Sonatype is the commercial guardian of the whole Maven and ecosystem, I would say. And I don't think that's a bad deal. I mean, really, this community service that they're providing for the past years, it's really helped Java grow. And if you're using it in any commercial capacity, and if you're depending on it, then this is a good idea. You want to exit it by HTTPS. Now, there is an open repository, the open source repository.sonatype.org, oss.sonatype.org, which is sort of an alternative, but it's not really an alternative because it only contains a subset, mostly of the more recent components, and it's really not built for the kind of traffic that Maven Central was built for. So if we're all going to do that, that won't scale. And if you're really paranoid and you're thinking about it and you say, okay, HTTPS, yes, it's secure, but we know about a lot of breaches in the last few years in certificates, etc. So in the Netherlands, we had a company called DigiNotar who was really popular, or unpopular, I would say, because they lost their root certificate, which allowed anybody, any hacker to get a certificate that was signed by DigiNotar, which was trusted by all browsers, etc. So I mean, I don't know where you are in the paranoid scale, and this would be pretty low on my scale, but still, it's something you have to think about. So some other countermeasures that you could take. You could just say, okay, well, I won't use any automatic dependency management then. I will do everything by hand, and I will throw away Maven. I will just copy my binaries, and I will verify and check that we're okay. And, well, okay, nice. You've prevented a whole lot of attacks that I described, but still, it's of course not scalable. And we don't want to lose the convenience of the build tools that we have. So another thing that you could do is say, okay, I introduce a local repository manager in my company. And regardless of the whole security thing, that's something that I would recommend anyway for lots of reasons, which I won't go into now. But if you have this repository manager, you could either have it connected to the internet, so it proxies Maven Central and downloads the artifacts and serves them to your company. And in that case, you would have shortened the attack window because you only download once from Maven Central, and then it's in your local repository and you distribute it to your company. So that's not a complete fix of the situation, but it helps. There are also companies that I worked at that say, okay, let's do a local repository manager and just cut all ties to the internet. And we just don't do any automatic dependency retrieval from the internet. If you want something, you have to put it in by hand in this repository manager. And then you can still use Maven at your developer side, and it points to this local repository manager, and everything will be fine. Well, yes, it will be fine, but that really depends on who fills this repository then, okay? How do they assess the security of a binary? If it was compromised when it was retrieved and it was put in your local repository, yeah, you're screwed anyway. I mean, there is some things that you prevent. Again, you shorten the attack window, but it isn't really a end-to-end complete fix of this problem. So that's the manual verification that I'm talking about. And when I was talking about this, some clever people said, okay, but doesn't Maven have checksums, right? So it should be safe. And yes, Maven does use checksums to verify binaries against these checksums. So either an SHA-1 or MD5 checksum must be present for, can be present for a artifact in Central. And when Maven downloads it, it verifies this checksum. But the problem with checksums is the only input for calculating a checksum is the actual artifact. And if you control, as a hacker, the artifact, if you can replace that, well, then you can just as easily replace the checksum that goes with the artifact. You just calculate a new one and offer that one. So while checksums are very useful for detecting any transport glitches, download glitches, it doesn't really help us to check the integrity and the authenticity of the actual artifact that we downloaded. So it's an automatic check that really adds some value, but not the value that we're looking for here. And another side note is that if a checksum fails in Maven, currently it tries to re-download and then it will warn. It will not fill your build if a checksum fails. You can force this by setting this checksum policy property to fail. And I would recommend that because something is not right when the checksum is wrong. But, well, by default it doesn't. And as a side note, the MD5 algorithm to create a checksum is sort of broken anyway, in the sense that it's trivial to create arbitrary files that conform to this MD5 checksum, as has been researched and published. So, no, checksums are not the answer we're looking for, although it's helpful if you don't ignore it, right? So here you see the default situation. If a checksum fails, it says retrying, and if it fails again, it says, okay, ignore. So set your checksum policy to fail, and it will fail, and it will notify you. So we've seen some countermeasures, and they're not completely dependable. Is there something that will work? And that's when we get to using PGP, pretty good privacy. And pretty good privacy is nothing specific to Maven or anything. It's a product that goes a long way back, and it's used for either encryption or signing artifacts. And in this case, we're of course not so interested in encryption because we're downloading open source anyway, so no need to encrypt. But we're really interested in the signing part to ascertain the authenticity of an artifact. PGP itself was popularized by using it in email setting to sign your emails, so people could see, okay, that's really Sander who wrote this email and who signed it with his PGP key. But you can use it anywhere, I'd say. There's also an open PGP standard, so it's not, while it was a closed source product, there are open implementations of this whole protocol. And the interesting thing is that the signing is based on a asymmetric public and private key pair. So that's sort of like with SSL, right? But it's also different. We'll see that later. But you generate your own private key if you want to sign artifacts, and you publish your public key so other people can verify it. Now, as I said, there's a free implementation. The one that I'll show is the GNU PG, GPG, free implementation of PGP. And we can use that to verify our Maven artifacts. And why is that? Well, that's because in Maven Central, not only there is a jar and a POM and a checksum, but recently, about 3 or 4 years ago, I guess, publishers of libraries were also had to publish a signature, a PGP signature. It's just mandatory. If you want to publish to Maven Central, you have to add a PGP signature alongside your library. And not only for the jar file, but also for the POM file. Why is that important? Well, of course, if you control a POM file, you can just transitively include any other dependency and, well, you have a problem again. So now, if you are a publisher of a library, of an open source library, you would have your library, which you uploaded, but also this signature, which you create by signing your jar and your POM using your private key, which is, of course, not known to anyone. But then, of course, there's still a problem of actually enabling other users to verify that the signature was yours. And therefore, you have to publish your public key to a PGP key server, and other people can download the key and use it to make sure that your artifact is really authentic. It really comes from you. Question? The question is there a PGP key server for Maven Central? Not a dedicated one, but there is a key server that is, I guess, mandatory. That's the MIT PGP server to upload your key to. So that's hosted by someone else, not by Maven or Sonatype, but it's a widely known server where you can upload your keys. And the question is, with the default Maven settings, is this PGP key server mandatory or optional? I'll get to that in a bit, but in the default settings, Maven doesn't do anything with PGP currently. So, as I said in the beginning, it is possible to be more security conscious and to avoid these cross-build injection attacks to a high degree, but you'll have to work for it. And that's what we're going to do now. There will be several steps involved. And the first one is just getting the key, getting the signature, sorry. Because as it is, Maven doesn't download these signatures by default automatically, like it does for checksums, etc. So you will have to do that by hand for your dependency that you'd like to check. In this case, I have the Plexus Cipher library, version 1.7, and I append .asc. And I will get this signature. So in the second step, I'll just show what's inside this file. It says, okay, begin PGP signature. It's made by GNU PG version 1.4. And then you get a whole load of gibberish, which is of course the signature that you're going to have to verify. So luckily you don't have to apply this algorithm by hand. You can use the GPG, the GNU PG implementation, and you can use the option --verify. I'll give it the signature and the location of the jar file. That's of course in my local repository now. And then GPG says, okay, yeah, that's the signature, and it's made at July 26, 2011. And it's made by a key with a certain ID, HDD1BDFD at the far right. But I can't check the signature because I don't have this key, right? So that's the whole key distribution problem. So at this point, you're already kind of an elite programmer, right? Because as this tweet by Jason van Zijl says, who's the founder of Maven, and yeah, you're in the minority if you even downloaded this signature, because only 2% of the people who download the binary also download the corresponding signature, as it is currently. But that's going to change because you now all know about it and you will do it, right? Yes, okay, that's the answer. But we're still not there, okay? So the top command is just repeating the verify command of the last slide. And the green arrow shows that I'm feeding this key ID into a next command, gpg-s key server. And that's when I refer to this pgp.mit.edu key server, which means, okay, go look there for the key with this ID. And then it says, okay, I'm requesting the key, and it's found. It's a public key from Sonatype Inc. It's their Sonatype release key, which they have used to sign this artifact, and it's imported. Well, okay, mission accomplished. Well, not quite, because we only have the key now in our local key ring, but we also have to verify the artifact, right? So again, we do the verification step, which is again the same command, gpg verify, with the signature as input and the jar file as input. And now it says, okay, it's a good signature. I can check it against this key that I imported, and it's good. But, and this is these are the signs that it's good. We imported the key, and it's a good signature. But there's a question.
How could I get the key server of a jar? Is there a repository for that? Yes, this is the jar, this is the key server.
How can you get a key server for a jar? Well, currently you have to upload your public key to pgp.mit, this key server that's mentioned here. That's just mandatory if you want to publish to Maven Central. So all keys should be in there. Yeah. Yeah. But we're still not quite there, because we just downloaded a key, and GPG tells us, okay, the key is valid in the sense that it checks out with the signature, but I don't trust this key. It's not certified with a trusted signature. It's just some random key that you downloaded from the key server. I mean, anyone can upload a key to a key server. It's an open system. And anyone can say, okay, I'm Sonatype, or I'm Sandermak. It's just a piece of text that's attached to this key. So how can you now be sure that the key that you downloaded also originated from the actual person who it says it's from? And that's where the whole story sort of diverges from what is normal in the public key infrastructure of, for example, SSL. Because there you have these root authorities that everyone trusts. They can give out other certificates, and now these are trusted because your browser or your other client trusts this root authority. But in PGP, they said, okay, that's much too centralized, right? Because if one of these root authorities fails, then the whole system falls down. I mean, the whole DigiNotar story that I told at the beginning, it's really serious breach of this whole system if one of these root authorities fails. So instead of that, PGP doesn't use root authorities. No, it has a web of trust, which means that trust is much more decentralized. And unfortunately, this makes the whole story also a bit harder, of course. But as I said, security doesn't come for free. You'll have to work for it. So what does a web of trust look like? So we had this Sonatype release key, right? And the blue keys here are public keys, and the red keys are private keys. And the nice thing in PGP is that a public key can be signed by other people. And when you sign another person's key, you actually say, okay, I trust this person. I trust that this key belongs to this actual person. So in this case, when you go look at the PGP key of Sonatype, you'll see that it's signed by Brian F., John C., Damien B. And if you trust any one of these people already, then you're good, because trust is transitive. If I trust one of the people who signed this top-level Sonatype release key, then I'm good. If I don't already trust any of these people in my web of trust, because, for example, you're starting out with PGP and you don't have anything in your keyring, well, then you have a problem, right? And you could just say, okay, I'll sign one of these, but don't just do that. You have to make sure that the key is actually belonging to this person. And how do you do that? Well, PGP has this nice concept of, well, it's not actually a PGP concept, but it's more of a community concept of key signing parties, where you go face-to-face with people and you say, okay, show me your ID or whatever you need to be certain that this person is who he says he is. I mean, maybe sample his DNA or whatever. But it's up to you to make sure that this person is actually associated with the key. And then you can say, okay, now I sign it. And if you've done that, then you have this entry path in this other person's web of trust. And so you can expand your own web of trust. So in this case, if I would have wanted to get a trust relation to the Sonatype release key, I would have to go talk to Sonatype. But that's not really a person, right, who can go to a key signing party, I guess. But in this case, I modeled a scenario wherein I imported the key of Brian F. and I signed it and just applied a trust relation to this key. And then transitively, I also trust the Sonatype key because Brian trusts Sonatype, right? So obviously, it takes effort to create your web of trust, and you really have to pay attention to what you're doing. So this is not for the faint of heart, but again, it's the professional thing to do if you think about it, if you think about what can go wrong. So actually, I've heard that there's sort of a possibility to do key signing and key verification at the Sonatype booth if you're interested in getting your way into the web of trust of Maven Central. So I'd highly recommend that if you want to get that started. But for now, for the demonstration, I'd like to show it's not just a few people who trust each other. If you look at just a subset of the web of trust of the Apache Software Foundation, as visualized here, I mean, it's huge. So if you get your way into that, you will really see that you easily, at least for the Apache projects, will get your web of trust up and running. So now the last step, because of course we want to see it work all the way, right? We don't want this warning anymore about a untrusted key. The last GPC command that I'll show, and in this case I also use some other functions. I say I won't download any keys by ID anymore, by hand. I just say auto key locate from a key server, and in this case the key server should be the MIT key server. I'll give it some options to say retrieve keys automatically, and then in the third line there's our familiar verify integration again, using the signature and the jar. And in this case, actually we're all good. It says, okay, you have one ultimately trusted certificate. Well, yeah, duh, that's my own certificate. If I wouldn't trust myself, well, I don't know what would happen. And we have one fully trusted certificate, and that was the certificate of Brian that I trusted, assigned trust to by signing it. And that way you have a path to this Sonatype release key, and yes, it is good. The contents are good, and it originated from Sonatype. So now you're done, finally, verifying one dependency of your application. I don't know many applications that have only one dependency, do you? I mean, you have tens of them probably. So that will get really tedious if your application grows and if you have many applications. So somehow it would be good if you could automate this, right? And now, of course, we could script a lot of those things that happened in the previous few slides. But, well, that's not really a scalable solution either. Of course, it would be really cool if we got tool support to do this. So what I'll show you is a short demo of the Nexus repository manager, in which we can define rules to actually apply this PGP verification inside the repository manager. Just a small caveat, it's not available in the open source version, so you'll have to get a license to the professional version of Nexus to do this. But anyway, let's do the setup. In this case, I'm switching to a slightly different project, again defined by a POM, which in this case contains somewhat more XML, and we love XML, right? So first, I override the link to Maven Central, and I say, don't go to Maven Central, but go to my local repository manager, right? So in your organization, if you do this, you will probably do this overriding inside of the settings of your Maven installation, and not in every POM file, but well, for now this is visible for you and easy to do for me. I also override the link to the plugin repository, because as I said, Maven doesn't only download dependencies for your application, but also for its plugins in its own functioning. Also redirected to the repository manager that I'm running locally. And it's just a very simple project using JUnit as a dependency. And again, this Plexus cipher library that we saw in the previous slides. So the nice thing is that we know that this Plexus cipher library has a signature, right? That could be verified. And I can already tell you that JUnit 4.2 doesn't have one. So it got into Central before it was mandatory to create signatures. So what we're going to do is just build this application. Okay, and you'll see that in between building it, I'll call a little shell script, clean my local repo, which cleans out the actual entries of the dependencies in various places to trigger everything again. So otherwise, Maven wouldn't go download, and I wouldn't be able to show this demonstration to you. So now let's do Maven clean install of this project. And we'll see that it fails. And it says, okay, the following artifacts could not be resolved. JUnit, jar 4.2, and Plexus cipher 1.7, could not find them. Now, why is that? Let's switch to the administration interface of Nexus. And here it shows that I have a so-called procured repository. And a procured repository sits in front of a proxy to Maven Central, and it applies rules to artifacts. It allows you to say, okay, I'll allow this in my organization and not that, etc., etc. So currently there are no rules defined in this procured repository, which means that by default it will deny any download. It's a pretty sane default, I'd say. And in this case, we can do something just to check that everything works. We apply a rule to all groups, all artifacts, all versions, and let's just say that we approve everything and see if it works now. So I'll switch to my command line again, do the cleaning and install, and hopefully, yes, it will allow the downloads now. Now, that's of course not a very interesting situation, right? If you just say, okay, well, download everything, then this procured repository doesn't make any sense. So I'll remove this rule, remove it, and replace it with a much more sane rule, in my opinion, which is to say that I apply a rule to all groups, artifacts, and versions, but not this automatic approve, but the signature validation rule. And when I check this box, Yeah, here it says, if this option is enabled, artifacts with missing signatures will be denied. So if there's no signature, it will be not be served by this procured repository. So let's see how it fares now. I would expect the Plexus to be downloaded, but the JUnit to fail because, well, it doesn't have a signature that can be verified, right? And indeed, it says JUnit 4.2. So now we have a choice to make, of course. How do we solve this? Well, actually, it's pretty simple. We can say, okay, for this one instance, this JUnit 4.2, I'll just allow it without a signature because I've done my due diligence and, sorry, the other rule, of course, force to prove deny, it's approved. And now it should build, right? Well, not quite, because now something new surfaces. Maven says, oh, well, I couldn't find JUnit 381. Okay, why? Well, because the Maven Resources plugin depends on it. Well, what do you know? Okay, wouldn't have expected that, but in that case, I'll have to do my validation of this artifact as well, and if it's okay, then I'll say, okay, and I approve this artifact as well. And finally, I can build my application. Yes, there it is, build success. So I could have said, okay, approve everything down in this branch of JUnit and be done with it. But I would advise to be really conservative in what you approve and deny, not just whole trees of a repository, etc. I mean, in security, it's better to be conservative than to be too liberal. I mean, don't apply this to all ways of life, but don't take this as a photo advice, but in security, absolutely, be conservative. So, are there any questions about this? Yeah? Sorry? Okay, the question is, I said that the ASC file is required for upload to Maven Central, yes, but not 3 years ago. So everything before that still doesn't have a ASC file. And of course, you can imagine if you have 600,000 components in there and a lot of them don't have signatures, you can go around, email every author of the library and say, okay, I still need your signature, otherwise I'll throw it away, which is really not an option, of course, in a repository like Maven Central. So there will be lots of artifacts that don't have a signature yet, and that's a problem. And there may be some workarounds that can be done by either Sonatype, Maven, but currently that's just the way it is. So. Okay, let's get back. So, I mean, of course, this is important. Build your application safely, not just build safe applications. But there are also other things that you can do, of course, to ensure the security. I mean, you should also do security testing, penetration testing, maybe scan your binaries using one of the applications that can scan for vulnerabilities. I even heard of some people here at the show who have an agent that attaches to your JVM and that scans for security vulnerabilities at runtime. I mean, there are lots of options that you can do to do defense in depth. That even if malicious code got into your application, you'd still be able to neutralize it. So, and other things might be sandboxing the application, using Java 2 security, etc., to restrict what the application can do. Take a good look at your network topology. Of course, yeah, all common sense, but really important too. And some recommendations on build security. I really think it's beneficial for any other organization to introduce a repository manager. Whether or not you're even doing the whole procurement and applying the rules, etc., doesn't matter. As we saw in the beginning, you decrease your attack vector, but you also get all kinds of other really nice features that you want to use in your organization besides the security. So do that. Really, there's lots of good open source one, Argiva, Nexus, Artifactory. They all have open source versions as well. And please think about what you put in your application. I mean, we warn our parents, do not download anything from the internet, do not click on this binary, and yet every day, every nightly build, we download dependencies, we put it into our application, and we ship it, right? Not good. So, question.
Just wondering, is Nexus Professional the only repository manager who does this verification step?
Okay, the question is Nexus Pro the only repository manager that can do this verification? Currently, I believe it is. So, yeah.
So with the Nexus, show that it made sure that ANSI files were there, not quite sure if they weren't, but what about, doesn't have built-in like checking of that?
It does also checking of the signature. What it doesn't do is it doesn't check whether the key is in your web of trust. So it stops at step 2 of 3, right? So we had the third step where we also made sure that this key was really trusted by us. And that might be improved in the future, but currently it does. It makes sure that there is a signature and it's a valid signature, but not whether it's in your web of trust. So, does that answer your question?
Yeah, but if it doesn't check the web of trust, then doesn't that make it kind of worthless? The actor just has the key to the
Well, worthless is a big word, but it would be more useful if you would be able to also let it fail if it's not in your web of trust. I agree. Yeah. So last point here, audit your build process. So not just this PGP verification, but all aspects of your build infrastructure. Pay attention to it, because it isn't really easy attack vector if you don't pay attention. So about the security, the secure tools, the future, I mean, it would be really great if all of this were automated in Maven. At least maybe download these signatures if they're there and hopefully verify them. And, well, currently, as I said, it's not there. But let's make our voice heard and let's make a statement that security is important. And if we all want this, it will get there someday. So it's also a call to action for all of us to pay attention, and not just for yourself, but get on the mailing list, discuss this with us, and move this whole thing forward together. So if you've applied all of this, and if you do PGP verification, if you make sure it's in your web of trust, I mean, are you safe now? Is there nothing more you can do? Well, no, probably not. I mean, security is not binary. It's not either you're secure or you're insecure. I mean, the other thing I can tell you is that if you're using all the default settings and just using it as it is, then you're definitely insecure. And if you do this, you will be more secure. But as the gentleman noted, even if you employ something like Nexus Pro, things can go wrong. Well, if you do it by hand, you can also get your web of trust involved, and it will be better, etc., etc. But yeah, security comes in gradations, and I won't say you will be perfectly safe if you do everything I told you today, but you will be a lot safer than you were before. So are there any questions? And by the way, before I take questions, a lot of this talk I've also written down on my blog. If you follow the bit.ly link there, you will see a write-up, so you can look at it at home. And questions, please, if there are any left. The question is, have I published how I actually did this nice exploit of the demo, I guess, in the beginning? No, I haven't. But that might be a nice one for my blog as well. So I'll think about it. And
It would be nice for people to get, at least be aware of this how we are exploiting. Do you have one way to think how to resolve this? There might be people, multiple ways to resolve that.
Definitely, yeah.
Just open it up for the community to feedback.
Yes. Well, that was also my call to action, right? I mean, let's discuss this in the open, and let's be aware of this issue and do something about it. And it shouldn't have to be exactly what I said. It can be, there may be other solutions as well. But well, this is what I researched so far, and yeah.
Definitely provoking, so please publish it.
Yeah. Okay, thank you. Okay, well, thank you then.